welcome back, Mindsetters. I hope you guys had a great break because we are now moving on to paper 3. Paper 3 always needs all your focus, guys, so make sure you're focused. And those of you who aren't really doing paper 3, I don't know if it's still an option. Hey, Natasha, it is an option to do paper 3.
Well, not if they haven't chosen it already.
Yeah, I know, but I mean, like, they had to have chosen it to do it. If you're not doing paper 3, guys, don't run away at all. Focus, guys, because there are some things that they go through that you need as well. So you need to be able to do this to even do your papers. So just make sure that you stay with us throughout the show because we will be helping you out with lots of things. Over to you, Natasha.
Okay, thank you, Kaleko. Guys, just to clarify, obviously paper 3 is a section all by itself. It's its own little monster. And if you're doing paper 1 and paper 2, you really don't need much of the information from paper 3. Geometry doesn't come into play there, not with the theorems and that. But, I mean, geometry teaches you so much of logic, like you're going to see today. And there are one or two things that you still need for paper 2, like remembering that when a radius meets a tangent, that angle is 90 degrees. Those little things you do need to know, okay? But if you're not doing paper 3, then this question is not for you, okay? All right, so geometry question coming from March 2011, which is the supplementary exam from the beginning of last year. And geometry, always a favorite topic. I love geometry. I hope you guys enjoy it, even though I know it's not everyone's favorite. Let's have a look at the question. And guys, remember, whenever you do geometry, the best way to, the way you're going to get the most marks out of it or the most results is to know your theory. Because if you know those theorems and you know when to apply it, it's going to make life much, much easier. But if you don't know those theorems, it's going to be incredibly difficult. So make sure you understand your theorems. All right. So they say in the diagram, they give you two circles which intersect at D and at B. All right. AB is a straight line such that it intersects circle BCD, circle BCD being this one here below at the bottom at point E, and BC is a straight line such that it intersects circle ABD, ABD being the one towards the left, and it intersects it at point F, and then they tell you a few of the lines are joined. They then tell you that angle F2 is 180 minus 2x. So that angle is 180 minus 2x. And they also tell you that FC, which is the length of this triangle FCD, FC is equal to FD. All right. I always find it very, very useful to just look at the information that they've given you and try and decipher and write as many things as you possibly can on the diagram. Also, try to identify cyclic quads. Remember, cyclic quads have all 4 points on the circumference of the circle. So try and identify cyclic quads, see if there's exterior angles of that cyclic quad, or if there's a circle center, look for angle at center, and also identify angles in the same segment if you do have cyclic quads. So let's have a look at the drawing and see what we can figure out before we look at the question. Okay, and for this I'm just going to swap to a different color. All right. Okay, so remember guys, I told you that F2 is 180 minus 2x and that FD is equal to FC. So that means that FDC is an isosceles triangle. If it's an isosceles triangle, the base angles are equal. So that means that D4 is equal to angle C. All right, so that's because FD is equal to FC, and angles of a triangle would mean that D4 is equal to angle C. So using angles of a triangle, because we've got F2, it would be quite easy to find D and C using the fact that angles of a triangle add up to 180 degrees. At this point, I also want to try to identify a few cyclic quads because sometimes they seem easy to identify, but it can be a little bit tricky. So if we look at the circle that's towards the bottom of the diagram, okay, so we're looking at circle F, E, D, E, C, so that's the one here at the bottom. The cyclic quad there that we have with all 4 points on the circumference is going to be D to E to, what is that, B to C and then back there. Okay, do you see that that is a cyclic quad? We've got 4 points touching the circumference, so therefore DEBC is a cyclic quad. Okay, remember when you've got cyclic quads, there's things like exterior angle is equal to the interior opposite angle, those theorems that you've got to remember. So we've got one cyclic quad there, and let's look at the other triangle and see if we've got another one. Okay, sorry, the other circle, and see if we have another cyclic quad. You can see, and this is quite tricky, and especially becomes tricky when they've put two circles together. But this one, FD, oh, whoopsie, just need another color there. Let's try that again. So FD, and then go from to B, and then across all the way to A, and then back here. Okay, so hopefully you guys can see that. BFDA is another cyclic quad. Okay, so the cyclic quads we've identified already are A, B, FD. Okay, and that's in that circle there. And then in the other circle we have cyclic quad D, E, B, C, and that's in this circle on the left. Sorry, on the right of your screen it would be. All right, so we've already worked out that FDC is an isosceles triangle, so we can use angles of a triangle to help us figure out things in that one. Let's look at the first question. Now that we've identified a few cyclic quads and we've got an angle in that given, let's look at the first question to see if what we've written down so far can help us. All right. They say calculate with reasons in terms of x, angle DEB. So if we're going for angle DEB, that's this one here. All right, that's going to be that angle E1. All right, so that's really the one they want us to work out. Okay, so guys, what I'm going to do is this has helped us to identify, all these colors have helped us to identify the quads in that, but it's becoming a bit difficult to see which ones we're working out. So I'm just going to take off all of those colors and show you step by step as we do the working. Just remind you of what were the cyclic quads and the rest of it. All right. So DEB, remember we've identified that as angle E1. That's the angle that they want. It is also one of the angles of cyclic quads, DEBC. All right. There's different ways we could work it out, but possibly the easiest one is going to be from the fact that they've given us that F2 is 180 minus 2x. So if F2 is 180 minus 2x, and I know that FC is equal to FD, that means I can work out the value of angle C and the value of angle D. So let's write down the proof to this. And this is 9.2.1, and this is part A. We're working out angle DEB. Okay. So the first thing we're going to do is to work out angle C. Why do I need angle C? Well, if you look at angle E1 and angle C, those are opposite angles of a cyclic quad. Remember your theorem. Opposite angles of a cyclic quad add up to 180 degrees. So if I know what C is, then 180 minus that will give me E1. Okay, and we do know what C is because we've got F2. All right, so this is now in triangle FDC. All right, we know that angle C is equal to that one, D4. And the reason for that, it's because they told us that FD is equal to FC. Okay, and it is important when you set up your geometry proofs that you put reasons. Hey, remember you do get marks for those reasons, so remember to put in reasons that make sense. All right, so angle C is equal to angle D4, and that's because FD is equal to FC. We also know that angle F2 was equal to 180 minus 2x, and that was given to us. Okay. So if I want to find C and D4, I can say in that triangle FDC, I know that F2 plus C plus D4 is equal to 180 degrees. How do I know that? Well, those are the interior angles of that triangle. So therefore, those are equal to 180 degrees, and that's because of sum of angles in the triangle. All right, we know what F2 is, and we know that C and D4 are equal to each other. So therefore, I can say C plus D4 is going to be 180 minus F2, which is 180 minus 2x. And that's going to give me 180 minus 180 will cancel out, and I'll just get 2x. So therefore, C plus D4 is equal to 2x, but C and D4 are equal to each other, right? So remember, all I can do here is I can literally replace D4 with C because they're the same thing. And then I'll get 2C is equal to 2x. Therefore, C is equal to x. All right. Once we've got angle C as x, and then remember D4 is going to be exactly the same thing, well, angle E1 is just going to be 180 minus angle C because of opposite angles of a cyclic quad. So E1, angle E1 plus C is equal to 180 degrees, and that is opposite angles of a cyclic quad. Therefore, E1 must be equal to 180 minus C, and C was x, so therefore E1 is 180 minus x. All right, so I went through that in quite a lot of detail just to show you how you would build the proof up. So therefore, we've got now the value for E1, and that is 180 minus x. All right, so that's the first question. The next one says, calculate A. So there's A all the way there. So if you look at A, it falls into a few different triangles, but importantly, it falls into a cyclic quadrilateral. The cyclic quadrilateral that I showed you at the beginning, FDAB or ABFD, all right? That one that we saw in that circle there. Okay, so if you look at that cyclic quad, all right, F2 is the exterior angle of this cyclic quad. Okay, so if we're looking at A, B, F, D being your cyclic quad, then F2 is the exterior angle of that cyclic quad. Therefore, we know that it must be equal to the interior opposite angle, because that's what the theorem says. F2 is going to be equal to A, because F2 is the exterior angle of cyclic quad ABFD. So therefore, since F2 is equal to 180 minus 2x, it means that angle A must also be 180 minus 2x. So A is going to be 180 minus 2x, and that's because exterior angle of a cyclic quad is equal to the interior opposite. So therefore, A is going to be equal to F2 is going to be equal to 180 minus 2x. All right. So guys, I hope you are following this. It is a typical exam question. It's using all those different theorems that you know about cyclic quads. All right, so we're on to the very last part, which says, hence or otherwise prove that ED is parallel to BC. So ED and BC. Now remember, the way you can prove that things are parallel is by showing there's either alternate angles, corresponding angles, or co-interior angles. So remember, we know that this one is 180 minus 2x. That's just what we've proved now, because they said hence or otherwise. We've also worked out that angle DEB. What did we work out there? That one was 180 minus x. So we've got that's 180 minus x. We've got that A is 180 minus 2x, and we want to prove that these are parallel. So we're going to either look for co-interior or alternate angles or anything like that that we can find. All right, so let's have a look. We know that angle E1 is the exterior angle of triangle. Now I'm talking about a triangle, hey, not about a cyclic quad. E1 is the exterior angle of triangle AED. Okay, now this is when that grade 9 geometry comes into play, because we know that the exterior angle of a triangle is equal to the sum of the interior opposite angles. So therefore, what that means, and I'm going to try and put the working on the top here so that we don't have to keep flipping down. Okay, so therefore E1 is going to be equal to A plus D, and the reason for that, that's because of exterior angle of triangle. All right, so E1 is going to be equal to A plus D1. So I know what E1 is. E1 is 180 minus x. I know what A is. A is 180 minus 2x. So if I want to find D, it's going to be angle E1 minus angle A. All right, and that will give me the value for D. So I'm going to get 180 minus 180. They would cancel out, and I'm going to get minus x plus 2x. 2x minus x is equal to x. So therefore D1 is equal to x. So if D1 is equal to x, now have a look at how this has helped us, because now that I've got D1, remember I was looking to either show if those lines are parallel, corresponding, co-interior, alternate, I can see that C is also x. So C is equal to D1, since they're both equal to x. But if you look at the shape of that, we've got corresponding angles. Okay, we've got sort of this little F shape going on there. So C is equal to D1. Those two are equal. But those are corresponding angles. Therefore, so since these are corresponding angles, we can say, therefore, ED or DE is parallel to BC. Okay, because those were corresponding angles. All right, so we went through quite a lot of revision for paper 1 and paper 3. I hope that you guys benefited from all of that. Katlego, do we have any comments coming through?
I'm trying to check if we have some comments. For now, I don't think so. I think everyone's just really happy that they got to go through some paper 3. I think that is very important to them. Mm-hmm. Do you have anything that you want to say to them?
Well, guys, obviously keep revising, and exams that time when all you can do really is do as many past papers. Do as many past papers as you possibly can, all right? So I know everyone's in the middle of prelims and that, so just do tons and tons of questions, all right? And obviously send us any ones that you are having problems with. We will try to answer them. Okay, so for today, remember all we did is we went over paper 3, a paper 3 question which was on geometry using our theorems on cyclic quadrilaterals. And we also did, in the beginning of the lesson, we went over paper 1, which was calculus, and we looked specifically at the derivative graph. And remember that calculus is one of the biggest sections in algebra. So if you're really looking for a place where you can get marks, then that place in paper 1 is calculus. All right. So good luck and study hard, and we will see you next week. Back to you, Katlego.
Thank you, Natasha. So guys, I know that we couldn't go through all of the questions. I don't know, Natasha, if you can go back to that one question. I think someone just wanted to see the answer again on what the short question that you did.
Oh, okay. We can go over the, let's just find it.
Just the short question that you did.
The deriving.
Yes, the deriving.
Let's just see if we can find it.
If it's there somewhere.
I think it was here. It seems to have suddenly disappeared, Katlego. Let me quickly try and find it.
Yes, that's
there
it.
we go. All right, guys. So just a reminder of how we did this. Remember that with your deriving by rules, you need to have single terms. So that was really in essence what this was showing. You have to have single terms where there's no x in the denominator, there's no root signs, and there's no brackets. So what you want to always try and do is, if you have brackets, times them out. If you have a root sign, as we showed you in this question, you need to get rid of that root sign by using your laws for exponents. So in this question, the only little trick here was to change root of x to x to the power of a half. Okay, and remember we did that by using the laws of exponents. Once we wrote x as x to the power of a half, we got to a stage where we've just got separate terms. Once we've got single terms like these, we were then able to derive by rule. Okay, so the big clue there, have single terms so that you can derive. All right,
okay,
and good luck with the studying.
Thank you. So guys, good luck. Any questions that you may have, remember that Saturday is still a day, guys. We still have some Saturday shows, so make sure that you ask all your questions then. Remember to help each other as well, guys. Thank you to Liberty, and thank you for joining us, guys. See you next week, Monday, for some more maths. Bye, guys.